Alright, so in this video we're going to be trying to extract hero IDs from Dota 2. This is for one of my side projects where I wanted to automate the process of finding out the most optimal hero choice for a particular game. So in Dota 2 you have two teams of 5 heroes each, and there's a picking phase before each game where you pick from a pool of 115 or so heroes, and all of them are unique, so some of them perform better against others, and you can get quite a big advantage by picking the right heroes to counter your enemy strategy. So there are already websites out there which do this for you, like they analyze um, Dota match history to figure out how a certain combination of heroes has fared against another combination of heroes, and they tell you if they basically tell you which ones fared the best. So if you let the website know which heroes the enemy has picked, it can tell you which one you should pick in turn to have the highest chance of victory. So we already have websites which do that for us. I wanted to create a HUD which would extract these hero IDs from the game, send them to the websites, fetch the results, and show them to you as an overlay over the game. Which is why I looked into Cheat Engine and basically learned about it and made all those previous blog videos. Anyway, so we're going to let's. When I started off on this path, I had to have my hero ID change, right, so that I could observe the change through Cheat Engine. But that's kind of tricky because in order to repick a hero, which would cause the hero ID to change, you can only play live matches, like matches online with friends. Even if they're bot matches, they would be live. So Valve would end up banning me because I'm playing matches online, and any sort of application hacks I'm attempting with online matches are they're pretty strict about that stuff. So I got banned a couple of times, but then I found another way of looking at this problem, and I could mess with this approach in a lobby, which is an offline mode. So since I'm not online, I can do stuff, and Valve isn't too mad about it. So let's go through that approach real quick. I'm going to create a new lobby, and I'm going to be on the Radiant team, and I'm going to set bots to be enabled so that all the other slots are filled by bots. This is the picking phase. I'm just going to pick Zeus because I know his hero ID. With all of my experiments, it's 22, so I'll just pick him. I'm gonna skip ahead to the game, and I have cheats enabled for this lobby, so I can get myself infinite levels, infinite gold, etc. That's gonna help us observe the memory and see how our hero information is represented. So I'm gonna give myself some gold. Another reason for picking Zeus was that he has a global ability, so he can kill other heroes really easily. So easy to manipulate my stats without having to jump through a couple of hoops. So I'm going to start off with a few enemy kills, and then we're going to see if we can observe those stats through Cheat Engine. So just hold on for a minute while I get those kills. And Dota 2 is nice enough to let us have these cheats in lobbies so that we can experiment with heroes and builds. So we're just going to use the refresh command to refresh our ultimate and just keep killing a few enemies, and I think that's good enough. So we have 3 kills, 0 deaths, and 0 assists right now. And what we're going to do is we could search for these kills. We're just going to open up the game in Cheat Engine, and I ended up searching for the level because I felt it was easier. So right now we're at level 7, and we have the level up command, which lets us increment our level by any amount. So we're going to look for this initial value of 7, and then we're going to increase our level by whatever amount and search for the new value, and we're just going to keep doing that till we find a reasonable number of results. So that looks cool. We have like 6 results, and it's not just the level we're interested in. Remember, we're looking for hero IDs, and what I was looking for was an array of structures which held hero information. So if any of these values was part of such an array, or was part of such a struct which was itself part of an array, you would find the hero ID in its vicinity. So I'm going to search in a small address range around this this hero level, and I'm going to see if that range has the value 22 in it. And we actually do find a value, and it's located slightly before the level. So it seems like we have found a structure which holds the information for this our current hero Zeus, and it has space for it, the hero's level and the hero's ID, amongst other things. And we're going to browse the memory region and see what other information this structure holds. So right now we're at 3 kills, 0 deaths, and 0 assists. So let's see if we can find this data. We're going to right click and browse this memory region, and you can see this first value is our hero ID, which was 22, but you can also see our kills. Like that 3 represents our kills, and that 0 represents the assists, and the next one represents our deaths, or vice versa. I think it's deaths. No, well, we'll see soon enough. We'll get some assists and figure out what is what. But it really helps to go into the memory and observe these structures and identify them. And like once you know the layout, it becomes easier to observe what's happening in the game. So we have information about our current hero, and we're going to see if we can find other heroes around this, because if it was an array of heroes, we would see the second hero, that's Axe. We would be able to find his hero ID in this address range which we've entered. Since 2 is quite common, let's look for the third hero, which third hero being Sniper. So Sniper's hero ID is 35, so let's look for 35, and we do get a hit. It's 27B4. Let's see how far away this is from the first ID we found for Zeus, which was 22. So that's 27B4 minus 2584. Oh, that's a decimal, sorry. So that gives us 230, and we divided by 2 because we were comparing the 0th and the second entry in our array. The 0th one being Zeus and the second one being Sniper. So let's come up with a generic formula for the hero ID at a particular index in our array. So we have our base value, which is where we find Zeus's ID 22, and each following hero is offset by 118, so 118 times the index. So 0 will give us Zeus, and let's see if we can find the right value for the first dire hero, so that's Bloodseeker, and he would be at index 5 since he's the 6th hero in this array. So it should be 4, and that's correct. And if you look at the next hero, we get 64, and our table says it's Jakiro, and it is indeed Jakiro. So um, it seems like this array is pretty solid, and we can use it for our purposes to get the hero IDs. Um, there's really infinite ways, probably infinite ways, in which you can get the data you need from the game. If you really wanted to study the game thoroughly, you would just map out all the functions and see where they lead and the structures they use, and just reverse engineer the shit out of it and figure out what classes the data represents, and at that point you have total control over your game. I just needed to read data from my game, and this is enough for my needs, just being able to figure out where the hero IDs are. So we're gonna see if we can get one of our teammates an assist, and um, I just wanted to do this so that we can observe it in the memory section, like I had promised before. So as you can see, we still have the hero ID and the kills, but we have one for the assists now. So you can see how the game's storing our hero data internally, and you can go further in depth if you need, but that's all we need for now. We just need to figure out if there's a pointer chain which leads to this first hero ID, which originates at a static address. So we're going to see what accesses this address. So we have a few results here. This 16 isn't right. Like, you can't have a base address that you won't have a base address that low generally, and sometimes a cheat engine does mess up and looks at the wrong registers. So ignore small values like that. You can probably still find the base address by looking at the registers. So anyway, I found the appropriate base address. You would want to note down the offset though. So when you're looking at the instruction, so RCX and RAX are involved. As you can see, RCX is 0 and RAX has the actual base address. So 14 is the offset. Just note it down because we'll need it later to form our pointer chain. So we scan for this address. I forgot to reset the memory range, so just set that to 0 and FFF for the end, and we get one result. We're gonna see what accesses this as well, and there's a bunch of instructions, but they all have the same offset. That as you can see, it's 3B0. So do make sure that you note it down and scan for that address again, and we find a static address in this case. So this indicates the end of our search because that's what we were looking for. So just bring it down and copy the offset from the DLL image, which it specifies, and just enter the offsets, and that gives you your own pointer chain. And as you can see, it points to 16 in hex, which is 22 in decimal, so it is pointing to Zeus's hero ID. So that's great. We're going to make a few more entries for completeness. We'll make an entry for the second hero. Unfortunately, I can't copy paste the previous pointer chain I created, so we're just going to have to do it manually and increment our offset as we move to different heroes. So we're going to name this hero 1, and we're going to make one more for hero 2 and another one for the last hero, hero 10. And we're just going to modify the offset to point to the correct hero. So The last one's offset is going to be 118 times 9 since he is the 10th hero. That gives us 14, which corresponds with Pudge's hero ID. So our array is complete, and it's it's got all the information we need. This array holds up whenever you're playing on the Radiant side. Things change slightly on the Dire team for some reason, and we'll go into that aspect in the next video. I'll try to keep these videos short because I'm still new to video making, and editing these can get cumbersome. So I'll talk more about what to do when you're playing on the Dire team in the next video.